or this one, right? So don't get confusion here. In some literature or in some books here, right? So it is given as furka, and in some literature it is given as this one. Okay. So the furka method. So what is a furka method here? So this is also one of kind of the mixed combinatory synthesis, and it involves some steps here. It involves some steps. So for example, we are going to synthesizing the tripeptide. We are going to synthesizing the tripeptide by using 3 different amino acids, right? So where we are taking the 3 amino acids here, the glycine, valine, and alanine here. These are the 3 amino acids. These are the building blocks, right? So these are the building blocks here. These are taken as a building blocks or the starting materials, right? So these amino acids. So with help of these 3 amino acids, we are going to, right? We are going to produce a tripeptides, right? So how many tripeptides are obtained by these 3 amino acids here? You can see, and generally it involves some stepwise, right? So it involves some steps here. Okay. So yeah. So here in the step 1, right? The first step involves where the attachment of the, right? The first step involves the attachment of these 3 different amino acids with resin beads. Okay. So in the first step, what we are doing here, we are attaching these 3 amino acids with the resin bead here, right? So this the block, right? So this one is a resin bead. These are the resin beads here. Solid support. Resin bead nothing but solid support, as we discussed in the previous classes. Okay. So this is the resin bead here, or the solid support. When this glycine amino acid is attached with this resin bead, so it becomes resin bead attached glycine. Now we are attaching the alanine with this resin bead here. Then it becomes alanine attached, right? Alanine attached this particular, what is that? So the building block here. Now the valine. So now in the third step, where we are attaching this valine amino acid with this resin bead. So resin bead attached valine, right? So now after attachment of these 3 amino acids with the resin beads, right? Now you take these 3 amino acids, resin bead attached amino acids. Okay, you distribute these amino acids, resin bead attached amino acids in 3 reaction vessels here. In 3 reaction vessels, right? In equal portion. In equal portion. Okay. So then you will get here the resin bead attached glycine, resin bead attached valine, resin bead attached alanine. And in this reaction which is also same kind of compounds, same kind of amino acids are taken. And in here also 1, 2, 3, there are 3 reaction vessels. In 3 reaction vessels, we are taken same kind of resin bead attached amino acids in equal portion. Okay, means equally distributed. Now, right? So means where you can take in the reaction vessel. That is your second step. Now your third step. Now your third step. So now you what the third step involves here. Now you add the different amino acid. You add the different amino acid in each reaction vessel, right? So what we are doing, you add the different amino acids in different, right, in each reaction vessel. Okay. In the second step, all reaction vessels are containing the same kind of amino acids here. Okay. In the third step, what we are doing, we are adding the 3 different amino acids in each reaction vessel. Now it becomes, for example, in the reaction vessel 1, right? So in the first reaction vessel, this is second one here, this is third one, right? So in the first reaction vessel, what we are doing, right? So where, for example, we are added the glycine here. right? So we are added the glycine. Then it becomes already it is glycine, right? So in the first bead, right? The first bead is attached with the glycine here. Then the next glycine is going to attach with this glycine, because before adding this different second amino acid to this amino acid, you have to protect this one of the end here. Okay, you have to protect the one of the end, because here the amino acid having two reactive positions here, two reactive functional groups. Here the amino group, okay, and acid group here. Okay, so you have to protect this particular, right? You have to protect one functional group, either here the acid or the amino group here. For example, if you are going to protect the acid group, you convert this acid into ester here, for example, right? And if you are going to protect this amino group, you treat with the amino, amino group protecting, amino group protecting groups like FMOC, okay, or what is that, BOC, right? Butyl oxycarbamide here. So these are the protecting groups here for the amino group, right? So one of the any one of these end, either acid group or the amino group, should be protected. Now you add this one group protected glycine to this, right? Previously resin bead attached glycine here. Then you will get this linkage like glycine, right? And in the second resin bead is, right? The second resin bead is attached with the valine, right? And we are adding the glycine to this. Then it becomes valine and glycine, valine and glycine. And third resin bead is attached with the alanine here, and we are adding the glycine. Then it becomes alanine glycine. Okay, so same scenario will be applied, right? Same mechanism or the same method is applied for this second reaction vessel, but the different amino acid. Here we are added the glycine, but here we are going to add this alanine here, right? Then what happens here? Here is the glycine. Then alanine is going to attach this glycine. Then it becomes glycine alanine, glycinyl alanine, glycinyl alanine. Then valine, and we are adding the alanine here. Then valinyl alanine here, right? Valinyl alanine dipeptide. Okay. Now this particular alanine attached with the alanine again. So now alanyl, right? Alanyl alanine dipeptide is formed. And the third reaction, which is same method is applied, right? You same followed here, where the valine, the different amino acid, is added to this already resin bead attached glycine valine alanine here. Then it becomes glycine valine, valine, alanine valine here. Okay, so like that, in the third step, where we are added three different amino acids to the three reaction bases. Now, right? So you mix all three reaction vessels in one reaction vessel, right? Now what we are doing, just simply, right? So you mix all these three. Okay, take a big reaction vessel and you add this here, and you add this here, and you add this here, right? So all three reaction vessels dipeptides are mixed together in one reaction vessel here. Okay, now how many dipeptides are there in your big reaction vessel here? Here is three, here is three, here is three. Total 9 dipeptides. 9 dipeptides are there in your big reaction vessel here, right? 9 dipeptides. Okay, so you mix all these three reaction vessels in one reaction vessel. Okay, then the fourth step. Okay, and you distribute, right? So you mix all these three dipeptides in one reaction vessel, and again you take three different, okay, you take three reaction vessels and equally distribute, right? Equally distribute these dipeptides in three reaction vessels. Then each reaction vessel contains 9 dipeptides. Okay, each reaction vessel contains 9 dipeptides here. You can see here 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 dipeptides. This is also having 9 dipeptides. This is also having 9 dipeptides. Total 27 dipeptides are present in your 3 reaction vessel here. Okay. Now you add, right? Now you add the third amino acid. Okay, third amino acid to the above reaction vessels here, right? So the next step involves where again you have to add the 3 different amino acids in each reaction vessel, which are containing 9 different 9 dipeptides here. Okay. Now you add the different amino acids in reaction, each reaction vessel here. Then what happens here? You will get this particular. Okay. So then what happens here? So for example, here, right? So one more, right? So one more attachment, like if we are adding the glycine, right? So if you are adding glycine here, then glycine, and valine glycine and glycine here, alanine, glycine and glycine, right? Glycine, alanine and glycine, and valine, alanine and glycine, alanine and glycine, valine and glycine here. Okay. And like, yeah, so like that. So now we are, right? So glycine. So now we are getting 9 tripeptide, 9 tripeptide here. Here also same thing. Here we are added glycine here. Now in this second reaction vessel, we are adding the alanine here. Now it becomes glycine, alanine, valine, glycine, alanine, glycine. Okay, and alanine here, glycine, alanine, and alanine, valine, alanine, and alanine, and alanine here. So like that, right? So all are the terminal, right? The terminal amino acid is alanine here. And in this reaction, where the terminal amino acid is your valine. Okay. Yeah, the terminal amino acid is the valine. Here is a valine. Here is a valine. So all contains valine here. So like that, where we are getting the 9 different tripeptides in each reaction vessel. Okay, 9 different tripeptide in each reaction vessel here. Okay, now what you do in the next step? For example, if you, right, if you are going to stop the synthesis here, right? Again, you take same, right? So you take in one reaction vessel, right? So you take one reaction vessel and you add all these 3 in this one, all these 3 tripeptides here, right? So glycine here and alanine here, and here is a valine. So all these 27 tripeptides are taken in one reaction vessel, right? And what we're doing, so we are stopping the synthesis here. At this stage, we are stopping the synthesis. Then what you do? Simply you wash with mineral acids, dilute HCl or the hydrogen fluoride. Okay, right? You wash with dilute HCl or the hydrogen fluoride here, HCl or whatever the mineral acids. Okay, or what is that? Fluoroacetic acid, right? Fluoroacetic acid. All these are the right. So washing reagents here, right? Then this particular, right? So the bonding or the linkage between the product and your resin bead is going to cleave, right? So this linkage will be going to cleave here. Then your product is obtained in pure form, right? Or for example, if you are not stopping reaction at this stage here, after right, so after synthesizing, means after getting the tripeptide, for example, if you want to extend that synthesis, like you want to synthesize the tetrapeptide here, then what you do, simply you take all these in one reaction vessel here, and you equally distribute in three reaction vessel here, right? So each reaction vessel contains how many here, right? So each reaction vessel contains, right? So 27 tripeptides here, 27 tripeptides, 27 here, 27 here, 27 tripeptides. Now you add the different amino acids, glycine here, valine here, here is alanine, what valine. So, so you add the different amino acids in each reaction vessel, then you will get the different tetrapeptides here with increased number of tetrapeptides. So like that, you can do the synthesis, peptide synthesis here, right? So before going to stop the reaction here, simply you take all the products, okay, resin bead attached products in one reaction vessel, and simply you wash with the mineral acids. Then that resin bead will be washed out, and your compound or the product is obtained in pure form. So very simple method and very easy method here. Okay. So only thing is, so it completes in 4 steps here, right? So in the first step, what you do, simply first you take the 3 different amino acids and you attach these amino acids with the resin bead here. And in the second step, you take resin bead attached amino acids in 3 different, okay, so 3 reaction vessel here. And in the second step, right, you take these resin beads attached amino acids in 3 reaction vessels. And in the third step, okay, what you do, you add the 3 different amino acids in each reaction vessel. Then you are getting these 3 dipeptides in each reaction vessel, right? Now in the fourth step, what we are doing, you mix all these 3 amino, right, 3 vessels in one reaction vessel here, right? You mix all these 3 dipeptides containing containers are the vessels in one reaction vessel. And in the fifth step, you distribute equally in 3 reaction vessels. You distribute, right, these dipeptides in 3 reaction vessels. And in the sixth step, what we are doing, we are adding the different amino acids in each reaction vessel here. Then we are getting the, right, the tripeptides in each reaction vessel. In each reaction vessel, you are getting different amino acids, right? You can see, for example, here the dipeptide, right? So glycine, glycine, valine, glycine, alanine, glycine, glycine, alanine. So all are different only, right? All are different only. Here also same thing, right? All are different, but no two products are same in each reaction vessel here. Okay, so this is the mixed synthesis, right? And this method is called mix and split method. Mix and split method or Furka method here. So mix and split means what we are doing here, we are mixing, right? So we are mixing all these 3 in one reaction vessel here, okay? And we are splitting, right? After taking this, we are splitting in 3 reaction vessel. That's why it is called the mix and split, right? So here all are added here, one, right? So 1, 2, 3. These are mixed together here. Okay. Again, we are splitting here. So that's why it is called mix and split method. Very easy and very important method. So that is the mixed synthesis. Synthesis and the mixed synthesis. Uh, period. Production of the large number of compounds in a short period here, right? And for example, trying to synthesize a particular compound here, right? A particular compound. Okay, but when you keep the combinatorial synthesis, when you follow the combinatorial synthesis method, along with your required other, along with your desired compound, you will get some other additional products also. Okay, you will get some additional products also. For example, in the previous case, okay. So for example, we want, right? So we want to synthesis the valine glycine here, right? Valine glycine. This is our active compound, right? Because this is our desired compound. This is our desired compound here, and this is called a desired means our we call this is the active compound here, right? But when you keep the reaction, we won't get valine glycine single product. Along with this valine glycine, we are getting some other combinations also, like glycine glycine. Okay, valine glycine, alanine glycine, glycine alanine, valine alanine, alanine alanine. Okay, glycine valine, valine and valine, alanine and valine here. So these other products also obtaining here. Okay. So after completion of the reaction, you have to separate this active compound. You have to identify this active compound here. Okay. You have to identify this active compound, and you just use some separate. For example, out of 9 compounds here, right? One compound is the active compound. Remaining 8 compounds are inactive compounds. Inactive mean the sense they are useful compounds only, but the compound, our desired compound here. Okay. So how to pick up that active compound? How to pick up or how to identify that particular active compound here, right? So for that, we have some methods to determine the active compound or to pick up the active compound or to identify the active compound. We have some methods here. So what are the methods involved in the structural determination of the active compound? You can see, right? So the methods involved in this structural determination of the active compound. The first method is the micro manipulation, right? So the micro manipulation, generally the micro manipulation, it is okay, for the method. So in this, each bead, each bead in one of uh, by giving and testing, right? So that can be so micro manipulation. So in the micro manipulation, so what we are doing here, so we will take each product, right? We will take every product and we will cleave that product with, right? We will cleave that product with the, means cleave in the sense we will separate that product with the resin bead here, and we will test that product with the colorimetric analysis here. Okay, for example, in this particular example, right? So where this example, yeah. So in this example, just you take, we are getting 9 products here, 9 dipeptides, right? For example, assume we got the 9 products. Okay, so in manipulation, the micro manipulation method to identify the active compound here, to, right, you take first, you take this bead, right? So this product bead here, and you cleave this bead. Okay, you cleave this bead and you separate your product glycine. You separate glycine and glycine. Okay, and you test this glycine and glycine by colorimetric titrations here, right? So to identify the structure, to determine the structure, we have some qualitative, right? So qualitative methods are available. That is a colorimetric test here, the colorimetric analysis, and chromatographic analysis, and the color reactions, right? By color reactions, you can identify the amino acids here, and by colorimetric titrations, you can identify the that particular amino acids here, and by chromatography also, right? Chromatography like paper chromatography and HPLC. Okay, so HPLC also you can identify the amino acids present in that particular peptide. Okay, or nin-hydrin reaction, right? Nin-hydrin reaction. So these are the some qualitative analytical methods to identify your amino acids or the peptides here. Okay, so the micro manipulation method involves, right, the individual testing of the synthesized compounds here, right? So okay, so first we are cleaved this glycine with this particular resin bead. We separated here and we are tested this glycine and glycine, right? So when you tested here, we got this result, means that particular compound or the product is having glycine and glycine linkage. So this is not our desired compound, right? This is not our desired compound. So it is not active compound here, right? And now again you take the next, go to the second product here. Again you cleave this bond, right? You cleave this linkage between the resin bead and this valine and glycine here, right? And you test the terminal amino acids here with colorimetric titrations or color reactions or chromatographic techniques here. Then we are identified where the valine and glycine linkage here, right? So for example, this is not the active compound. Again, you take the third one, again, you take the fourth one and fifth one, every, right? So each and every compound should be tested, right, to identify the active compound here. That is your micro manipulation method, right? So when you test all 9 compounds, so out of 9, one compound is the active, other compound is the inactive compound, right? So okay, so this method, it is very tedious method here, and it is very time consuming method. Okay, so it is very tedious method, right? Because it is time taking process to test all the compounds, right? So it is very headache process here. Okay, that's why the micro manipulation method is not good method to active compound. Now the second method is a recursive deconvolation, right? The recursive deconvolation method. So recursive deconvolation method is what superior somewhat superior than your micro manipulation, right? So in this, some work will be cut down here. Some work will be reduced than your micro manipulation, right? So in the micro manipulation, where we are right tested all the compounds, all the synthesized compounds, but in the recursive deconvolation, so that thing is not repeated here. Okay, so what? So this is a better method, and it cut down the work, right, amount of work here. Right? So this recursive deconvolation, it involves that, right? So when we are going to synthesizing the tripeptide, for example, right? When we are going to synthesize the tripeptide, right? So in the third step, what we are doing third step here, where we are adding the, right? Where we are adding the third amino acid. Okay, we are adding the third amino acid to the dipeptide here. Okay, so in this particular method, right? So in this particular dipeptide are preserved, right? This the third stage is, or the third step is retained, or it is stored here. It is stored, right? You store the these third step products. What is the third step product here? Dipeptides, like this one. Okay, so this is your step 3. So stage 3, these third stage products are, it is preserved. Okay, it is preserved here. And after completion of the reaction, right? So here you see the third 1, 2, 3, right? So the third step, right? The third step products are preserved here. And after completion of the peptide synthesis, right? Simply you add the, okay, simply you add this amino acid, same amino acid, right? So in the mixed synthesis, what we are doing, we are added the 3 different amino acids, 3 different amino acids in means to this dipeptides here, right? But here, if we know the terminal linkage of the amino acids, okay, means for example, if you suspect that, right? If you suspect AV, okay, we are suspected AV in the tripeptide, the terminal linkage is AV, for example, right? So to find out this, okay, so to find out this linkage, right? Simply you add the valine, right? To add the valine to these dipeptides here. Okay, so where, right? So to this particular reaction vessel, we are added the valine here. Now we got this glycine valine, right? So our target is the terminal, okay, the terminal linkage is AV. Okay, so this is our target, means our active compound. Our active compound is having AV linkage in the terminal, right? Or the last 2 amino acids are AV, alanine and valine. Okay, so it is easy to find here. It is very easy to find out. Okay, so what we are doing here, simply we are attaching this valine, right? We are attaching this valine to all 3 dipeptides here, and we are see that, right? So here you see glycine valine here, right? So glycine valine. So this is not our required other desired or your active compound here, right? So our target molecule is having AV. This is our target here. We are going to find out the AV linkage. Next, we are added to this second dipeptide, valine, glycine, valine, right? So this is also not our you, right? This is also not the active compound. Next, alanine, glycine, valine, right? Alanine, glycine, valine. So this is not our active compound. Okay. And to this second pool of the dipeptides, right? To the second reaction vessel or the pool of the dipeptides, we are going to add same amino acid here. So when you add, right? So glycine, alanine, valine. Okay, glycine, alanine, valine. Now, valine, alanine, valine. Okay. Next, alanine, valine here. Right. Okay. So now it is found that, right, our AV linkage, okay, our AV linkage is present in your second reaction vessel, right? So the terminal amino acids are same in second pool of the reaction vessel here, right? Yeah, the in second reaction vessel, the terminal amino acids are same. Here AV, here AV, here AV. And now you check the third amino acid, the third reaction vessel. Same, you add that valine to each dipeptide. So now glycine, valine, 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 alanine, valine, and valine. So these are also not active compounds. Okay. So it is found that the first reaction vessel is not containing the active compound, and your third reaction vessel is not containing the active compound here, right? It is found that your second reaction vessel is containing the active compound terminal amino acids here. Okay, so these two, right? So these two means these two reaction vessels can be removed. So no need to now. Okay, now we are identified the second reaction vessel, right? So simply you take the second reaction vessel and you perform the colorimetric reactions or the ninhydrid reaction or the color test or the chromatographic test here, right? So it is easy, right? So out of here the 9, right? Here is a 3 total 9 here, right? So out of 9, so 6 here 3 and here 3. So these are neglected. These 6 compounds are removed, right? So you need to test only these 3, right? So it is somewhat means the where the work, right? The work done is reduced here. Okay, so the effort will be reduced, and it is somewhat time saving process here. Okay, but in the micro manipulation, what we are doing, each and every compound should be tested. But here, no need to test all 3 reaction vessel dipeptides here. Only the second pool or the second reaction vessel testing is required. No need to check the first and third one. So like that, this is the somewhat better. This is somewhat better method in the identification of your active compound here, right? So these are the methods, and some one more method, and the advanced method is there. That is the coded sheet. Okay, so coding method here, decoded method. So decoded method, but it is not there in your syllabus. Okay, so decoded method, it is advanced technique than your uh, recursive deconvolution and micro manipulation method. Okay, right. Next, example is right? Okay. So in this combinatory synthesis method is applied and applicable in these two major fields here, like polypeptide synthesis and the heterocyclic compound synthesis here. Okay, so we'll see one example with the heterocyclic synthesis by combinatorial strategy, right? So here we are going to synthesizing the 1,4, right? 1,4 benzodiazepine 2-one, right? 1,4 benzodiazepine 2-one. So this compound is going to synthesized by combinatorial synthesis method here. Okay, so this to synthesis of this particular compound, right? Uh, okay, so this is the structure of the compound, right? So this is the structure of your diazepine, benzodiazepine 2-one, azepine here, right? Azepine means 7 carbons with nitrogen. Okay, diaza. Diaza means 2 nitrogen. Here the 2 nitrogens are there and 7-membered ring here. And the benzene is attached. So benzo, diazepine 2-one. Here the ketone group is there. At second position, it is ketone group. So 2-one here. Okay, right. So to synthesis this particular benzodiazepine 2-one, right? So here these are the precursors. Precursors means starting material, right? At this compound. Okay, benzophenone, right? Benzoderivative, and this particular amino acid here, and here the alkyl halide. These three precursors are used to synthesis this, but benzodiazepine 2-one. Okay, so the strategy involved in this synthesis is yeah. So this synthesis benzodiazepine 2-one synthesis can be done by the element solid phase synthesis here, right? Element solid phase synthesis. It is one kind of element. Element is a it is in bead, right? So in bead here, element solid phase synthesis. So the reactive group, or the functional group, active functional group, which is going to with your linker, right? Linker. So the carbon group is there and the X is there. So both are reactive groups here, right? To avoid the formation of the side products or the byproducts, right? We have to protect this amino group with the amino group protecting group. That is a FMOC. Okay, amino group protecting group. That is a FMOC here. FMOC is the amino group protecting group here. Then, okay, it is protected with a FMOC. Now we are going to attach the resin bead. That is a tentazole resin, right? So we have tentazole resin, Wang resin, okay, Merrifield resin, Wang resin, tentazole resin. So these are different types of resins here. Okay, and the Merrifield resin is very commonly used resin here. Okay, so the resin to this particular benzophenone derivative, right? So this resin bead is attached with this particular compound, right? Now, right, see the amino group is protected. Amino group is protected, right? So now we are going to react with the precursor, right? The second precursor, like this here, the three precursors, 1, 2, and 3. These are the starting materials here, substrates. Okay. materials. This one means starting materials. So first we are taking this starting material where we are protected this amino group with the FMOC here. Now we are going to attach second precursor to the resin bead attached to first precursor. Right? But to react this amino acid with this particular resin bead benzoquinone, right? So this group is protected. Amino group is protected. So what you do? We protect this amino group with 20%. Okay, 20% piperidine. Right? This is your piperidine. 20% piperidine is taken. So this piperidine protects some. Then your amino group is free in form to react with the next precursor here. Right now, this is free in form here. See, free in form. So now we are going to attach this particular amino acid with this amino group here. Okay. So in the amino acid also we have the two reactive functional groups like amino group and acid group here. So the amino group is protected here. So the acid group can be reacts with this particular amino group and it forms a peptide bond. Forms in this peptide bond. Okay. So now the third, right? The third precursor also there is involving in the next step here. Okay. So we take this summer group here, right? Again, we are doing the 20% pipe here. Then the summer group is deprotected. It is obtained as a NH2 here. It is in the free form, right? Now, in the case of right, acetic acid, in the presence of acetic acid, this is undergoing the cyclization where the minus H2O, right, with the water, hydrogens, right? Here the two hydrogen here, right? Two hydrogen and this oxygen. This oxygen, it is removed as the water, right? So by condensation of this group here, it is undergoing the cyclization and dehydration. So it is going to form the seven-membered ring. Seven-membered ring here. Okay. Now we are going to attach your third precursor. Third precursor here, this one. Third precursor is going to attach with this one. So this RX alkyl halide is attached on this nitrogen. So N alkyl product is obtained here.